Okay, this is the question from 2024 May June paper 2 variant 1. A ball is released from rest at point A and moves along a smooth track A B C D E. The track is shown here. As shown in figure 1.1, the ball is shown at point A and as it passes B, the ball is always in contact with the track and air resistance is negligible. Figure 1.2 shows the distance time graph for the ball as it moves from A to E. Okay. On figure 1.2, mark with the letter P one point where the ball accelerates. Guys, it's a distance time graph. The gradient of distance time graph gives us speed. So if we are looking for a point where it is accelerating, that point should be a point where the speed is increasing and the gradient of distance time graph is speed. So where the when we will see that a point where the gradient is increasing, it means the speed is increasing and the object is basically which is ball here will be accelerating. So here we can see the gradient is increasing. So we'll mark here with letter P. With the letter Q, one point where the ball has constant speed. If the gradient is constant, the speed is also constant. So the gradient is constant where the line is straight. So we can see here, we have a straight line at this section. So this is the point where we are supposed to mark Q. Determine the speed of the ball at point X on figure 1.2. Where is the point X? Okay. What is the difference in normally asking speed while giving distance time graph and in this question? Normally, when they ask you to find the uh, speed while they give you distance time graph, we know the gradient is the speed. But the problem is normally whenever they ask you in previous years about the speed, like these type of questions, they give a straight line section where we just find 2 points and find the gradient. But here the problem is they are giving us 1 point, but that point is on a curve. But the formula that we use y2 minus y1 over x2 minus x1 is for a straight line. So what to do with these type of questions? Remember, whenever they ask you either acceleration or speed by using graph and you are required to find the gradient for that particular answer and it's a curve. So you have to draw a tangent. So what I'm doing here? I am drawing a tangent here. You know what is tangent? Tangent is a point, is a line which is touching a curve at a particular point, like it is a curve, and this is the point. So if I draw a line like this, and this line is touching the curve at that particular point, so this line will be called tangent. So I have drawn tangent here. Now, this is the line for which I am going to find the gradient. So I'm choosing 2 points here. One point is, let me make it a better tangent. It would be more better like this. So I'm choosing this particular point. At this point, if I go on x-axis, I'm getting 1.5 after 1.6. 6. This is 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65. 1.65 and on the y-axis I'm getting 2.9, and this is the point we have 0.3, and at 0.3 here we have 0.4. So y2 minus y1. First I have to mention here that speed is equals to delta y over delta x. So 2.9 minus 0.4 divided by 1.65 minus 0.3. So 2.9 minus 0.4 divided by 1.65 minus 0.3. So I'm getting 1.85, which in two significant figure will be 1.9. Units are already mentioned here. Remember, when these type of questions come, they always give you a range because every student may get a different answer according to the tangent drawn. So they will give you a range that from this point, this value to this value, if there is answer, it will be considered as a correct answer. So right now I am on the boundary, I'm getting 1.9. So the range that they had given is from 1.9 to 2.4. Whichever you are getting in between, it will be marked as correct. Now, the speeds of the ball at A, B, C, and D are VA, VB, VC, and VD respectively. Arrange these four speeds from slowest to fastest. Okay. You can see here that at A, it is at rest. So at A, the speed is 0, so it is the slowest. Okay. And now, as it goes down, the speed will increase. Then again it goes up, the speed will decrease. And then it goes down, the speed will increase. So because when it goes up, the speed again decreases, and again at this point, the speed is very less. Now again it will increase from this point. So the next point for which, because object is not going that higher, so it will not reach the zero speed, but it will get a little less speed. So after point A, a little bit more speed is at point C, and then at D the speed increases further. So at point D the speed is more than C, and because from A to B it has gone too far, so its speed will increase more. So here the ways are the how we are going to compare them. At A the speed is lowest, after that a little more at point C, after that point D, and the highest speed is at point B. So at A it is slowest, then at C, then at I guess D it was now, and at B here it is the fastest. And if you see the distance time graph, where the gradient is increasing for more, where it is more steeper, the speed is more. So you can see here when it is going from A to B till point X, it's more steeper. So it is gaining more speed. Then the speed decreases and it increases again, but not that much because it is not that steeper. Work is done to transfer energy between energy stores as the ball moves from A to B. Name the force involved in the work done and describe the energy transfer. Obviously, at the highest point, it is at rest. It has the potential energy, gravitational potential energy, as it goes down, it will gain kinetic energy. So name the force involved in the work done. Which force is give and take work done? Obviously, which is pulling it downward. It is the gravitational force. The gravitational force pulls it downward, and then gravitational potential energy gets converted into kinetic energy. Why is it lagging? Why is it kinetic energy? Because its speed is increasing. Initially, the speed was zero. The track at B is circular in shape. On figure 3.1, draw an arrow to show the direction of the resultant force on the ball at point B. Uh, when something is in a circular path and it is at particular point, the direction of resultant force is towards the center. So it is perpendicular to the object. So it will be like this, which is centripetal force. Now, this is the question from 2024 May June paper 2 variant 2. Okay. Figure 1.1 shows two trolleys. On the front of trolley A, there is a wooden rod. Trolley B is initially at rest. Okay, right side trolley B is at rest and trolley A is moving. As trolley A moves towards right, the rod enters the modeling clay. Modeling clay is there on the rod on the trolley B. You can see here, and because it's clay, so then the wooden rod strikes it. Obviously, it is going to penetrate into the clay. So trolley A slows down and trolley B starts moving. The trolleys then stick together and continue moving towards right. This is the speed time graph of both the trolleys. Back, and you can see at this particular point, they both have the same speed because they are stick together. The trolleys start to collide at time t is equals to 0.30 and t at t is equals to 0.50. The trolleys are moving at the same speed. State how figure 1.2 show that during the collision, trolley B has a uniform acceleration. It's a speed time graph. The gradient gives us acceleration. And during the collision, we can see when the speed is decreasing, it's a straight line. A straight line shows that the gradient is constant. If the gradient is constant, it means acceleration is also constant. So that's what they are asking. State how figure 1.2 show that. During the collision, trolley B has uniform acceleration and acceleration speed is increasing and it's a straight line, so the gradient is constant. Gradient is constant, showing uniform acceleration. Describe how the graph in figure 1.2 shows that the magnitude of the acceleration of trolley B is larger than the magnitude of deceleration of trolley A. It's a gradient. So the one which has a steeper graph will have more gradient and it has more acceleration by magnitude. Acceleration and deceleration are both acceleration, but the deceleration is negative acceleration. So they are asking in terms of magnitude. You can see here that for B and for A, it's quite obvious that which one has more gradient. So it is written B is larger than magnitude of deceleration of A because the gradient of B is greater than that of A in terms of magnitude. Calculate the acceleration of trolley B when t is equals to 0.40 seconds. Acceleration of trolley B. T is equals to 0.4 because it's a straight line. It's up to you whatever the points you are taking. I'm taking this point 0.5 and 0.4. So 0.5 comma 0.4 and this is 0.3 comma 0. So 0.4 minus 0 and 0.5 minus 0.3. I'm getting 2. So I am getting 2.0 meter per second square in two significant figure. The mass of trolley A is 0.80, the mass of trolley B is 1.6, 0.60. Show that momentum is conserved in the collision. Law of conservation of momentum, total momentum before collision should be equal to total momentum after collision. So total momentum before collision is before the collision the trolley B is at rest, but the trolley A has a speed of 0.7. So A has mass 0.80 into 0.7. Momentum is mass into velocity. So I'm just multiplying mass by velocity. And because initially trolley B is at rest, so its momentum is 0 because momentum will be only present when the object is moving. So 0.8 into 0.7, 0.56. Now total momentum after collision. So because they stick together and moving with a common velocity, so we'll take one mass, which is the combined mass 0.80 plus 0.60 and their combined velocity. And what is their combined velocity is 0.4. So 0.8 plus 0.6 multiply by 0.4. Yes, I'm getting 0.56 again. So total momentum before collision is equals to total momentum after collision. Now, in another collision between the same trolleys, the rod and modeling clay are not present. Trolley A hits trolley B with the same initial speed. Explain why the force between the trolleys is larger in this collision. So, they are saying in another collision between the same trolleys, the rod and modeling clay are not present. So there is no wooden rod, there is no modeling clay. They both are going to collide directly. Trolley A hits trolley B with the same initial speed, which was, I remember, 0.7. Explain why the force between the trolleys is larger in this collision. We know here that when there was uh, the rod and modeling clay, so when the rod is hits the modeling clay, it penetrates into it, slows down, it takes time to hit, to come in contact with the other trolley B. So it is taking more time. So force between the trolleys is larger in this collision. But now when there is no clay and no rod, they are coming in contact directly. We know the change in momentum. Force depends upon change in momentum over time. If there is more time, the force will be less. If there is less time, when there is no rod and no no clay. So when there is no clay, no rod, they will collide directly without the delay, and they will take less time. So less time will cause more force because of this formula. That force is rate of change of momentum. It is in the topic of momentum there. So I will write, since force is equals to change in momentum over time in absence of modeling clay and rod, the time will decrease. Now, this is the l- question. I don't know. Let me check the year. I got it. This is the question from paper 2, variant 2, October, November 23. Okay, the spacecraft of mass 300 kilogram is moving in a straight line in space at a speed of 8,000 meter per second. Calculate the momentum of the space. Momentum is mass into velocity. Mass is 300, velocity is 8,000, 3 8s are 24 and 5 zeros. So it will be 2.4 exponent 6 kilogram meter per second is the unit of momentum. The fuel on the spacecraft explodes and the spacecraft splits into two parts, the direction of which the parts move does not change. After the explosion, the speed of the front part increases to 9,000 meter per second. It has a mass of 150 kilogram. So, a spacecraft was moving initially at 8,000 meter per second. Now it explode. The fuel on the spacecraft is explode in the spacecraft splits into two parts. Let's say this is the one part and this is another part. And they both are moving in the same direction still. And the speed of the front part increases to 9,000. The front part has the speed of 9,000 meter per second. It has a mass of 150 kilogram. Calculate the speed of the rear part after the explosion. Okay, just for the it was for the explanation, so I'm moving it to right side. Okay, initially the mass of the whole part was 300 kilogram, whole spaceship. So if one part has 150 kilogram, then other part is also 150 because combined together they will make 300. So they are asking you, uh, To calculate the velocity of the rear part, again, conservation of momentum, total momentum before collision is equals to total momentum after collision. Before explosion, total momentum before explosion is equals to total momentum after explosion. So before explosion, we know the momentum was 2.4 exponent 6, and after explosion, it is split into two parts. So one has 150 mass and speed is v, and the other has also 150 mass, but the speed is 9,000. So 2.4 exponent 6 is equals to 150 v plus 150 into 9,000. I'm getting 1.35 exponent 6. If we subtract it, so 2.4 exponent 6 minus 1.35 exponent 6 divided by 150, I'm getting 7,000. 7,000 meters per second. The total kinetic energy of the two parts after the explosion is greater than the original kinetic energy of the spacecraft. State the energy transfer that occurs in the explosion. What is the energy transfer is taking place? Obviously, the fuel chemical energy is converting into the thermal energy in the explosion. No? So in the explosion, we have energy, chemical energy in the fuel. Kinetic energy. The explosion lasts for 0.20 seconds. Calculate the average force on the front part during this time. So for the average force, force is change in momentum per unit time. Front part. So initially, front part was combined with the rear part as well. So initially, the part had the momentum that we calculated, and it was 1.5 exponential. Let's calculate it. mv minus mu over t. So mass of the front part is 150, which I'm taking common. The final speed is calculated here, which is 7,000. And initially, it has a speed of that we had here 8,000. Front part has the speed not 7,000. Sorry, that is the speed of rear part. The front part has a speed of 9,000 and divide by time, which is 0.20. So 9,000 minus 8,000 is 1,000, multiply by 150 divided by 0.2. I'm getting 7.5 multiplied by 10 raised to the power 5. So this is the final answer. Um, for this, Newton is the unit which is mentioned. So we have covered all the questions of dynamics and kinematics along with momentum from 2018 till 2024.